Everyone, just a quick video to show you some of the stuff purchased from eBay. It came in this nice little enclosure. You can see compartment sectioned off. I'm just going to go through some of the stuff that I got here. So what I got here is a little stepper motor driver based on a single chip. As you can see, everything is labeled nicely, and you just need to solder pin headers there. Here you are. This can do up to 30 volt and up to 1 amp. And later on, I'll after the video, I'll do the test on this. I already got one hooked up. I just bought these to test the stepper motors that I've got to start making my CNC machine. This is not the one I'm going to use for the actual CNC machine, but this is just for something, testing purpose and stuff like that. It was quite cheap anyway, so I got about 4 of these. I've got a little accelerometer gyroscope. Yeah. So it does y-axis, z-axis and x-axis, and you feed it plus or minus, and then you got the 3 outputs. I've tested this and it works really good. It's quite cheap as well, so I bought about 3 or 4 of these as well. I got a little parallel to I2C converter. It was cheap as well, so I just got a few of them. I'm not going to use this in my CNC machine, but I just thought it'd be a good idea to test it and see how it works. I got a little current sensor. It's a Hall effect current sensor, so you feed in your plus and minus here, and then whatever your voltage you want, whatever current you want to sense, it goes through here. So you feed the positive, and then you got output there, and then this Hall effect sensor will sense the current. These are quite cheap as well, so I got these. Got a little USB to UART. If I'm doing work on microcontrollers, so I don't have to pull out the microcontroller and program it or talk to it. I can just use this and use it in breadboard. You can see it's got these little pin headers. You can just there we go, insert it into the breadboard, and you insert your wire, and then you can just wire this through your microcontroller. But 5 or 6 of these, they was quite cheap, so I thought why not. I bought little breakout boards. Yeah, I do a lot of work sometimes and things like that on ICs, so I'll need to solder them, and then I do prototyping and test on them as well. So I usually make these myself at home, but you know, these were so cheap, I said, you know, there's just really no point of me wasting time trying to etch my own board, so I just ordered different ones from eBay. I ordered some of these prototyping boards as well. I think these are the same size as the Arduino, so you can, like, you know, you can put your pin headers there and just mount this on Arduino, and then you can do your prototype in the middle. I've got these footprints as well. For some of the digital analog converters I have, they're in this package, so I thought I'd just buy some of these as well. It's a QFN44 pin package, and these are sub 16s. So these were quite cheap as well. I bought them. I bought some ultrasonic transceivers, so you got the sender and transmitter and the receiver at the same side, and you got the little circuitry here to drive it. So you got the output, you got the echo, and you got the trigger. I just bought these just to do some work and stuff on them, because I've never used ultrasonic before, so I thought it'd be a good way to learn about how they work and stuff like that. I bought little radio frequency receiver and transmitter. These work I think about 10 to 12 meters apart. The only problem with these is they're very noisy on the receiving side. So you need to put a little, if you want to send data and stuff like that. First of all, they don't do really fast, you can't really transmit fast data with these. And the other thing is, if you send in data, say from one Arduino to another or Arduino to something else, you need to have some form of filter to filter the noise on this, because it's really noisy. So you lose some data on it. So you're gonna need to have, you know, some form of authenticating data and some form of error checking and stuff like that. So by doing that, you can't really send data across this fast data. So it's usually used for turning things on and off and sending, you know, simple signals across and stuff like that. So I thought I'd just buy some, do some play around with them, see how they work and see what I can do with them. Another thing I bought was, as you remember, I used to have these chargers for my lithium ion cells. So you had the IC there, and then you had the you had the IC there, and you had the LEDs to show you the status for charging and standby. Now they've done an upgrade to this, and it looks like this. And what this one's got, it's got the extra charger there again, but it's got some protection circuitry there. So it's got the under voltage cutoff. So I'm gonna do it later on. I haven't done a test on this to see at what voltage the cutoff comes in and how it works and stuff like that. So I'm just gonna do a test, separate video test on this, and see how the under voltage cutoff works, and how does the charger work. Is it still charges the same as this one? Because this one charged up to 1 amp. I need to find out how this works. So I'm just gonna do a little bit of video some other time on this and see how this works. But these were quite cheap, so I bought about 30 of them for my cells, lithium cells. I've got a little high frequency transceivers. I think these work up to I think about 2.4 gigahertz or something like that. I bought this for Arduino, and this one's got the built-in regulator on board, because these ICs work with 3.3 volt, and as you know, the Arduino is 5 volts, so it's got a little converter there, so it converts the 5 volt from Arduino to 3.3, so this IC can handle it. I've got a little Bluetooth transceiver for Arduino as well, just to do some tests and stuff like that. Here we are. And I've got the same 2.4 gigahertz transceiver, but this time this doesn't have the built-in regulator on board, so this can only take 3.3 volts. So if I'm working with Arduino with this, I need to build another 3.3 converter and then maybe mount this on top, because these pin headers are quite small. They're not standard pin headers, 2.54, so I'll probably mount this on another board, and then another board will have the voltage regulator and the right pin header pitch to convert to connect into my Arduino or breadboard. So that's for some of the stuff that I had got from eBay. What I'm going to do is I'm just going to connect the by the way, these are the stepper motors that I was talking about that I got. Here we are. I think these are German built. I quite like the way they've got this on top, so mounting this on whatever I'm gonna mount them on makes life easier. These got the 6 pins. They got 2, which is the middle tabs, and then they got 4 on the other side. The stepper motor driver that I got are designed for unipolar stepper motors, which these are not. So what I'm gonna do is I'm gonna just use these 4 pins. I'm not gonna use the center tabs. I'm just gonna use the other 4 pins to make it kind of a unipolar, and it does work perfectly fine. There's no issue with it whatsoever. So I'm just gonna show you how this works. The little IC, the little breakout board that I bought requires obviously frequency for the steps. So I'm gonna use my function gen. There we go. Just put this here. It's a bit of a mess, but this is just for testing purposes. Well, the IC runs from 5 volt. And then you gotta feed it a separate voltage for your motor, obviously. Okay, the frequency that I'm set this This works up to 1.5 kilohertz. It doesn't function properly after above that, but that might be because of the stepper motor that I have. So I'm not 100% sure if you put another stepper motor it might work differently. So I'm just gonna turn it on. I'm just gonna feed it power. I got a little capacity here across the voltage rail of the stepper motor. Here we go, as you can see. Okay, now this IC does micro stepping and all kind of other goody stuff it has on it. I haven't really gone into it to see properly the functions and what you can do with it, but I've just connected it from a datasheet. I read from datasheet, and it's, as you can see here, so I can control the speed and the stepping with the it's got 3 inputs to it, so you can control the stepping and the resolution of your motor with those 3 wires. So if I just pull one out, as you can see, it's going much faster. If I put it back again, it's going a bit slow. If I pull this, it's a little bit faster, and if I pull this, it's gone a little bit faster. As you can see the difference. If I pull this, and obviously you got the direction as well. Here we are. It does have an enable pin, so once you activate the enable pin, deactivate it, sorry, everything shuts off and it doesn't take any current at all from the power supply. Here we go. So I thought these were quite good. That's why I just purchased them, because they were quite cheap. I have ordered a few other. I think there's an improvement version of this IC. I've ordered that from eBay. I also ordered some H-bridge. I think it's L298N for driving stepper motors and different other motors, other kind of motors. What I've done, I've also ordered some PIC micros. I think they're the DS family, the digital signal processor family. And I've seen a video on YouTube that someone uses a DS PIC 33 and a H-bridge to drive stepper motors really fast. So I've ordered some of that. I ordered some of the chips direct from Microchip, which were quite cheaper than buying from anywhere else. So I'm just waiting for them to come. They should be here within the next couple of days. And then I'm just going to do a little test jig to see if I can make these run as fast as that I've seen the guy to do it on YouTube. So yeah, that was just a quick video. By the way, I have 4 of these stepper motors, as you can see here. So I only need 3 of them for my CNC machine. But yeah, the CNC machine is going to take a long time to do, because I've never built anything like that before. So I'm just going to go with it, and slowly try to see what I can build. I'm not going to make a full out, big ass CNC machine. I'm just going to make something, maybe a tiny version of it, because as I said, I don't have that much room in my lab, because I've got all other stuff and my work that I do for living, parts and stuff like that, there in my room as well. So there's not really that much room to have a big ass CNC machine in my lab. So I'm just going to build a smaller version, make sure it works everything fine, and then once I'll probably move out to a bigger room, then I can make a proper size CNC machine. And another thing, I think I didn't do a video on the actual dummy load that I was doing. As you can see here, I've finished it now. Oh, I finished it a while ago, but I forgot to do a video on it. Here we are. So you got the switch. If it goes up, you go into charging mode. If it goes down, and you got your dummy load. I've got the fine tune and normal. So with this, I can tune the scale of the dummy load. So if I'm just got it if you just got it halfway, then this becomes finer, and if I go all the way up, then obviously we get less, so the steps increase. So yeah, it's quite a neat little box, and it's good to have, because I wanted something that be self-powered and is small to have on my, you can see here if I bring the camera, yeah, on my desk, small form factor, and it can do up to 2 amp. Sorry, 1.5 amp. I've put this. So yeah, that's that, and all done now. So what I'm gonna do next is I'll do a video on testing those chargers board that I bought from eBay, and then I'm gonna do another test on these, proper test on these, to see if I can connect this to a microcontroller and control the steps and directions all at the same time with the microcontroller. So I don't know what I'm going to use. I'm going to use PIC or Atmel, but yeah, that's something that I'm going to do in the future. So yeah, thanks for watching. If you liked the video, as always, give it a thumbs up, and until next video, goodbye.